Hi, and welcome to Week 4 Tidbits on graphing linear equations. We're going to start off by plotting some points, figuring out how the points work to a solution of an equation, graph a linear equation by two different methods, use the slope formula to help us calculate the slope, and then use that to write equations of lines. Let's begin with just the basics about plotting points. Before we go into graphing linear equations, we have to make sure that we understand our field of what we're graphing it on. Now, we've started out in the past and we've had our number line. It was a horizontal line with a 0 in the middle and positive numbers to the right and negative numbers to the left. And we could plot our solutions of x is equal to something on that line. Well, what's happening is that in life we ended up finding that there are oftentimes relationships between two different variables, and so we need to relate those variables together. So since we have a second variable, we need a second axis. This is called the x-axis, with all of our x values, and then the next letter is the next one consecutive in the alphabet, so we call it y. It goes right through the 0, straight up, and straight down. This would be the y-axis. If you're positive, or if you're in a good mood, you would go up, so the positive numbers are up, and the negative numbers are down. Now, we oftentimes do not write the little numbers in our grid because it gets a little busy. You just assume in math land that the increments are all 1 unless it's noted otherwise. If you're talking about the x-axis and the y-axis together, the plural of axis is axes, which looks like axes, but it's pronounced axes. The two axes have now divvied our space, which we call the rectangular coordinate plane, or the Cartesian plane, into 4 spaces. Those spaces are called quadrants. Quad meaning 4. We identify our quadrants with Roman numerals to indicate the difference between our Arabic numbers. We always start where the two coordinates, the x and the y, are positive, so that's up here. So that's quadrant 1, and then we go counterclockwise from there. That's quadrant 2 is II is the Roman numeral 3, and then the Roman numeral for 4 is indicating that it's 1 before 5. Well, 5 is a V, so 1 before that we put the I before the V, and that's your Roman numeral 4. So the 4 spaces are called quadrants. Now we're going to plot points on our coordinate grid, and points are just that. It's a dot. It's a spot of location. It's telling us the location. Yeah. The same. Another word for points would be coordinates. You oftentimes hear about, oh, we're out to sea and these are our coordinates, and they talk about latitude and longitude. Those are same idea as what we're doing here. It's just on a 3-dimensional plane. Another word for points would be ordered pairs. Ordered pairs are another word for coordinates, because they're a pair of numbers because we have to have an x and a y, and they're in a particular order. So all of our points have an x value first, then a y value. It's alphabetical. It's essentially like playing Battleship or looking up a map before we had our GPS do it for us, and identifying that, oh, the city or I'm firing at G3, and either I hit or I missed one of your ships on Battleship, or there's where your city is looking for on the map. Those are coordinates, those are points. We're essentially doing that same thing when we plot points here, except instead of having letters and numbers, we have numbers and numbers. And that's why they have to be in a particular order. So if I had the point 2, 3, I start at this where the axes meet, that is the origin, it's the beginning of all things. And if it's the point 2, 3, I go x 2, which is 1, 2, positive here. And then from that point up 1, 2, 3. And right there is the point 2, 3. To be in the second quadrant, maybe it's something like -1, 2. I would go back 1 and up 2. -1, 2. To be in the third quadrant, both of my coordinates would have to be negative. Say -3, -2 would be here. -3, -2. Notice that all of my points have parentheses around it and a comma to separate the two coordinates. That is correct notation. Technically, it's not a point if it doesn't have the parentheses around it. So keep that in mind. And let's see, one over here. How about we do 3, -1. So we go 3 and then down 1. 3, -1. And that's how you would plot a point. So what's going to happen now is that we're going to be given an equation that has both an x and a y value in it. We can't solve for x because there's another unknown y, and we can't solve for y because there's another unknown x. But we can find out how they work together. So if I have something like y is equal to 3x minus 2, I can find out if certain coordinates or points would fall on this particular equation by seeing if it holds the equation true. So if I had the point 2, 4, and I want to know, is that a solution? Well, we need to remember that a point is always an ordered pair. So the first coordinate is an x value and the second coordinate is a y value. Well, up in our equation we have an x and a y. So I'm going to replace the value of 2 for x because it's in that first spot. The x value is 2, so I'm going to replace it with 2. And similarly, I'm going to replace the y with 4. So here's our same equation, but I'm going to replace the y that was in front with 4 because it's the second value. I'm going to replace the first one with 2. And now we simplify the left side and the right side and see if they equal each other. On the left side, there's nothing to do. That 4 will just come along for the ride. On the right side, I have multiplication. That's our other indication of parentheses. And I have subtraction. According to our order of operations, PEMDAS, please excuse my dear Aunt Sally, we do the multiplication before we do subtraction. So 3 times 2 is 6. 6 minus 2, sure enough, is 4. Therefore, it checks. What does that tell me? Is that point a solution? Yes, it is. Now here's the thing. With the equation y equals 3x minus 2, that's not the only solution. We are so accustomed to having only one solution when it comes to an equation. X is whatever. We've solved for that one problem. But now because we have an x and a y that's working together, we have more than one solutions. Let me test 1, 1. Once again, I'm just going through in the equation doing the exact same thing. I'm replacing the y value with 1. And then I'm going to replace the x value also with 1 and simplify the two sides. Once again, we do our multiplication first, and 3 minus 2 is 1. So this also checks. So this is a solution too. What happens is that we have an infinite number of solutions. We have an infinite number of solutions. Now, it depends on what we put in for x, but we can always find whatever number we put in for x, take it times 3, and subtract 2 and get a y value. Does not matter what type of x value I have. I can use negative numbers. I can use fractions. I can use decimals. Any number I stick in here, I can subtract 2 and I can come up with a y value. So any number that's on our number line, I can come up with a y value that goes with it. So there's an infinite number of solutions. And that's finding a solution to a line. Plug in the x and the y and see if the left side equals the right side. Now that we know that there's an infinite number of solutions, we can plot those points as we just did in the previous and connect the dots and see what kind of pattern it gives us for that equation. That's one of our techniques for graphing an equation. So that's going to be next. There are three different ways that you can graph a linear equation. Now, y equals 3x minus 2 is a linear equation because x and y are both to the first power. We don't have any squares or ugly things like that. So that's what makes it a linear equation. So we've already determined that the point 24 and the point 11 are both solutions to this equation. Can you find others? Yeah, it doesn't matter what we pick for our x value, we can come up with a y value as I stated in the previous segment. If we continue on with a positive, if we put in a 3, 3 times 3 is 9 minus 2 gives me 7. So the point 37 is also a solution. That's getting a little bit high, so I'm going to start going down the other direction. And what happens if I put 0 in? Oh, I like 0. 3 times 0 is 0, and then I just take away 2. So I have the point 0, negative 2. Let's do one more, just because this is kind of fun. If I stick a negative in, 3 times a negative 1 would give me a negative 3. Negative 3, take away 2. They're both negative, so we add them and keep the sign, is a negative 5. So now I have 5 different points. And what I'm going to do is I'm going to go on my grid here that I drew out, and I'm going to plot those points. The point 2, 4, remember we're plotting points, we always start from the middle. We go right 2 and up 4. 1, 1, we go right 1, up 1. 3, 7, right 3, up 7. 1, 2, 3, 4. Ooh, starting to get a little bit close to being off my grid. 0, negative 2. Straight down. As we go left and right, nothing, and then we go down 2. Negative 1, negative 5. There we go, and we've now plotted our 5 points that we had. What do you notice about those 5 points? Well, if I had drawn a very nice grid here with all my increments being exactly the same, it would be very clear to tell that they all fall in the same line. Now when we say line in math land, we're talking about a straight line. Saying straight line is actually being redundant in math land. A line is something that you would draw with a straight edge. Not that I have a straight edge on me, but we'll make do with what we do have. If you just connect the dots, you see we have a nice straight line that goes through all 5 of those given points. And we continue. I put little arrows on the end, top and bottom, because this line goes on forever and ever, because once again I can choose any x value that I want and plug it in for y. So one of the methods of graphing a linear equation is to come up with points. Now a more organized way of coming up with those points is to make a chart. Call this a table of values, and you just make a chart with x's and y's, and you choose x values. Choose x values, and it can be anything you want. I like 0 because things cancel out when we multiply by 0. If you're afraid of the negative numbers, stay away from them. Just do 0, 1, and 2. Those are your x values, and then you plug those x values in and solve for your y. How does that look? Well, similarly to what you did just before. But now we don't know what y is, so y is equal to 3, and my first spot was 0. So I'm going to replace the x with 0, and now I just simplify. 3 times 0 is 0. 0 take away 2 gives me a negative 2. So that y coordinate is what will go in the y value here. and then make your point. There's your point, 0, -2. Just what I came up with over here. So coming up with 3 values, now technically to draw a line you only need 2 points. 2 points determine a line, but 3 makes it better. Because if we made a boo-boo on one of our points, lost a negative, something of that sort, our 3 points won't line up in a straight line. You'd end up with more of a triangular thing. So that would let you know that you made a boo-boo someplace and that you should double check your math, especially if there were negatives. So that's one technique to solving or to graphing linear equations. Make a table of values, come up with 3 points, plot the 3 points, and connect the dots. Ooh, what were those steps again? Let's do that one more time. Graphing by plotting points. Make a table of values, choosing values and solving for the choosing x values and solving for y. Then your second step is to plot those points. And my favorite, connect the dots. Three easy steps to graphing a linear equation. The great thing is, there's shortcuts to that, and we'll get to that in the next section. Another way to graph a linear equation is by using what's called the slope-intercept form. This identifies the slope of the graph and the intercept, but we cannot graph using that technique if we don't know what either of those means. So first of all, we're going to go through, and I have that same equation, y equals 3x minus 2, and I made that same table of values and I extended it to -2 all the way to 3. Now I want to notice patterns. Patterns are everywhere in our life, and especially in math land. So let me look at a few things here. If you look at my x values, all I did here was I increased it by 1. Every single time to go from -1 to 0, I increased it by 1. To go from 0 to 1, I increased by 1. 1 to 2, I increased by 1, etc. I have the same process of increasing by 1 every single time on the x value. Now let's see how that relates to the y side. Is there some sort of pattern there? Well, on the y side, I go from -8 to -5. That's an increase because -5 is closer to 0 than -8, so it's greater than -8. So I increased by 3. To go from -5 to -2, I once again increased by 3. To go from -2 to 1, I increased by 3. To go from 1 to 4, we increased by 3. And the same thing of 4 to 7, we increased by 3. So every time we added 1 on the x side, we added 3 on the y side for this particular equation. Now, if we go through, that 3 to 1 relationship is right here. The number in front of the variable x, when y is by itself on the other side, is called the slope of the equation, or the slope of the line. Slope tells us how steep our graph is. Okay? It tells us the rise over the run. So we rise 3 and run 1 because all whole numbers can be written as fractions. That's 3 over 1. The top number is always that increase of your y. Rise are y's. The denominator is your run, or how far you moved left and right. You have to rise out of bed before you can run a marathon. Okay. So what exactly is that slope again? Slope tells us the steepness of our line. Is it kind of flat? Is it kind of sharp? Something of that sort. Slope also tells us how we move vertically and then horizontally from one point to another point. On our line. Let me move that up for you. Slope tells us how we move vertically. Now remember, vertically is up and down, and then horizontally. Horizontally is left and right because that's with the horizon, from one point to another point. From one point to another point. So here is our line. Here's one point. Here's another point. To move there, pretend that this is an old video game that we don't have the diagonal. You have up, down, left, right. To get from this point to that point, we would go up 1, 2, 3, and then to the right 1. Pick any other points. How about going from this point to the point we have up here? Up 1, 2, 3, to the right 1. Now you need to remember that a positive 3 over a positive 1 is the same thing as a negative 3 over a negative 1. So I could also go from this point down 1, 2, 3, and then back 1, and look, I'm still at that same point. From this point, I can go down 1, 2, 3, and back 1. Down 1, 2, 3, back 1. Every time I do that, I get to another point that's on my line. That ratio of 3 to 1 is the slope of the line. Because 3 is fairly large, you see that our line is fairly upright, not too flat. Also notice that because that slope is positive, if you look at the graph from left to right, it's rising up. Whenever you read a graph from left to right and it rises, your slope is positive. If it falls, you have a negative slope. Okay? So that tells us a little bit about slope. But if we're going to graph using a slope-intercept form, we have to be aware of what an intercept is as well. If we don't know what an intercept is, we're not going to be able to find our slope-intercept form. The intercept is where our line crosses an axis. Now the intercept in the slope-intercept form is going to be the y-intercept. It was just a little bit too hard to say slope-y-intercept form, so they just simplified it to slope-intercept form. But in the slope-intercept form, it is always the y-intercept that's being used. Okay. So this is where our line is crossing the y-axis. Now let's think about that for a moment or two. If I have a grid like so, okay, and I have a line that goes through here, let's say it goes like that. What would the coordinate be of the y-intercept? Well, remember the vertical is our y-axis, so the point where the line, that orange line, is crossing my vertical axis is right here. Now what's the coordinate of that? How do I travel to get to that point? Well, from the origin, I would go left and right nothing and up 2. That would be the coordinate of that particular y-intercept. Now let's say I had another one. Say I had one that went like this instead. What's the coordinate of that y-intercept? Well, once again, to get to this point here, from the origin, I go left and right nothing, and then I go down 1, 2, 3, 4. So that's the negative direction since I went down. So the coordinate of that y-intercept is at 0, -4. What do you notice that's common about both of those? The x-coordinate is always going to be 0. For us to be a y-intercept, we have to be a point on the y-axis. To be on the y-axis means that when I plot my point, I went left and right nothing, and I only went up and down. So a y-intercept is the value of y when x is 0. It's the value of y when x is 0. So to find a y-intercept, you replace x with 0 and solve for y. That tells you the y value that your graph crosses on the axis. Well, let's go back one more time to y equals the 3x minus 2. So we just said that a y-intercept is found by replacing x with 0. And then you solve for y. So if we do that, we have y is equal to 3 times 0 minus 2. 3 times 0, oh, it's 0. 0 minus 2 just ends up being negative 2. So where our graph crosses the y-axis is at negative 2. Right down here. That's always a point that's plotted up or down, never left or right. So how does that help us graph if we know the slope and we know this intercept? Well, the slope, remember, was how you travel from one point to another point. Well, that's all fine and dandy, but if we don't have one point to start with, how can we move vertically and horizontally to get to another point? And that's where the intercept comes into play. Once again, our equation is still y equals 3x minus 2. Now, if we think about this, if there's some number here that's being multiplied by x, and if x is 0, we're always going to end up with this last value here being our y-intercept. Every single time, the number that's here with the sign in front of the term goes with the term. The sign here, or the number here, will be the y-intercept. That's where we plot up or down. So at this, we can tell right away from the equation that the y-intercept is at 0, negative 2. So you can plot that point. We go left and right nothing, we go down 2. Bloop. Then from there, we can do our slope, because our slope says that's how we move vertically and then horizontally to get from one point to another point. Well, now that we have one point, I can travel to another point by rising and running that slope. So from this point, I'm going to rise and run the slope. And remember, the slope, we said, is the number in front of x. If it's a whole number, you want to write it as a fraction over 1. So that you see your rise is the numerator, your run is the denominator. So from here I'm going to rise 1, 2, 3 and run 1. And now I stopped, and so that's where a new point is. I rise from there, I can repeat that 1, 2, 3 and run 1. I can continue that as many times as I would like, and once again see that I have this nice straight line. So what was that technique to graphing by using the slope-intercept form? Slope-intercept form. Maybe I should start writing that on another page. I think I will. The slope-intercept form is when y is all by itself. Y equals mx plus b. This is officially the slope-intercept form. Once again, we're not really tricky in math land. It's called the slope-intercept form because it tells us the slope and it tells us the y-intercept. Thus, it's called the slope-intercept form. The slope is m and the y-intercept is b. So whenever you have y all by itself on one side of the equal sign and all this other stuff on the other side, the number in front of x is your slope and the number by itself, or the constant, is the y-intercept. To graph in that form, the first step is plot the point 0, b. That's the y-intercept. From there, rise and run the slope. Remember, that's from that y-intercept. So from that y-intercept point is where you rise and run the slope. I would do that at least twice. Make sure that once again we have a nice straight line that we can follow. And then step 3, once again, is our favorite, connect the dots. So after we rise and run the slope, we make another point, and then we rise and run the slope again, make another point, and connect those dots. Those 3 steps is how you graph using the slope-intercept form. Now sometimes the equations are set up nicely that you can use more ideas of intercepts, and you only need 2 points to plot to graph those. That's going to be next on graphing by using intercepts. Sometimes your equation is given in the general form, and that would be having x's and y's on the same side of the equal sign. So it's in the form of ax plus by is equal to c. Example of that would be something like negative 4x plus 6y is equal to 12. Now that's just fine and dandy, and that's not too bad to actually graph in this form either. Instead of rearranging the formula so that you get y all by itself, there is another technique in order to graph this, and that's by using the intercepts. Once again, as we just discussed, intercepts are where the graph crosses the x or the y axis. Now we're going to use both of those. We've talked about the y-intercept before, and we know that the y-intercept is where the graph crosses the y-axis. So we replace x with 0 and solve for y. That's how we find the y-intercept. Well, it's going to be very similar in order to find the x-intercept. To be a point on the x-axis, though, it means that we moved left and right, but we did not move up or down. So instead of x being 0, the y-coordinate is 0. And then we solve for x. And that's how they are related. Now, when we have the equation as such, I like to just call this the cover-up method. Now let me show it again. Let me rewrite that. Once again, we have negative 4x plus 6y is equal to 12. Now if I want to find the y-intercept, it means that I'm going to replace x with 0 as we just stated. Now I could go through all that math and say, okay, negative 4 times 0 plus 6y is equal to 12. And now I have to solve. But what's going to happen whenever I replace one of my variables with 0? I multiply here, and I'm going to get 0. Wow, 0 plus 6y is equal to 12. That's a little silly. We don't have to write that. It's just 6y is equal to 12. So the term with the y is all by itself equal to the constant that was on the other side. And then to get y alone, we would then divide by 6. Remember, a number and a letter mushed together means multiplication, so to cancel multiplication, we divide. And we would get y is equal to 2. Now, how did I get y is equal to 2? I replaced x with 0. Right now, write the point 0, 2. That's how you got it. That is very important for using the intercept method. You need to remember that if you're using the intercepts, one of your coordinates is going to be 0 for your points, always. one of your coordinates is 0. Now that's all fine and dandy, but like I said, there's got to be a faster technique to this. And I agree. If you go up, and since this first term is always going to cancel out, I just go up to the original and I cover up that first term. And I say, okay, I'm left with 6y is equal to 12. Well, now I just have that last step, and I can divide both sides by 6 easily in my head and get the fact that y is equal to 2. Either way, I'm still getting this as my point, 0, 2. Now to find out my x-intercept, I do the exact same idea, but this time I'm replacing y with 0. So 6 times 0 here would cancel out. So once again, I'm just going to cover that up, and now I solve. I have the equation negative 4x is equal to 12. Negative 4x is equal to 12. And that I, once again, should be able to solve in my head, but I could write it out too. And divide both sides by that negative 4. Negative divided by a negative is a positive, leaving the x alone. Positive divided by a negative is a negative. And there are 3 4s in 12. Once again, though, this value of x came about because we replaced y with 0. So the point is negative 3, 0. Now that we have those 2 points, we just have to plot those 2 points and connect the dots. There's always going to be 2 points there. Again, let's just transfer those over to the next page. We had the point 0, 2, and we had the point negative 3, 0. Remember, intercepts will always have 0 as one of the coordinates. I can't stress that enough. So many times I have students plotting points out in the middle of space because they put the 2 together. How do you draw a line if you only have the 1 point? We're doing this to find 2 easy points so that we can plot just those 2 points and connect the dots. So remember, intercepts, you have to have 2 points. Now remember, we did 3 points when we made our table of values, and we essentially did 3 points with the slope-intercept form because we did the slope twice. That's just to make sure that we're accurate. You don't have to have that. As I stated before, 2 points determine a line. That is all you need. So the first point is 0, 2. So remember, we start at the origin, we go left and right 0, we go up 2. Bloop. Our second point is at negative 3, 0. Once again, you start plotting a point by the origin. I'm going to go 3 in the negative direction, and I go up and down nothing. So I'm right here on bloop, the negative x-axis. Now that I have those 2 points, I can connect the dots. And that's how you graph using intercepts. So once again, what did we do? We find y-intercept, which is 0 some number. Then we find the x-intercept, which is some number 0. We plot those 2 points. And our favorite, we finish up by connecting the dots. So the 3 techniques for graphing equations is doing a table of values. Make a table of values, plot the 3 points, and connect the dots. Or if you want to do something a little bit faster than that, you can do it by using the slope-intercept form when y is all by itself. It's a 1y is equal to mx plus b, and then the slope is in front of x and the y-intercept's there. And once again, in order to graph, we don't really do a whole lot of math here. We plot that point on the y-axis, and then from that point we rise and run the slope and repeat that. So we're counting is about the most math that we do there. And then of course we connect the dots. Or if you want to use the intercepts, when your equation's in the general form of having x and y on the same side, you can use the intercepts by replacing x with 0 and solving for y for 1 point. then replace y with 0 and solve for x for the second point. And after you've done that, plot those 2 points and connect the dots. Those are your 3 techniques to graphing. Now, of course, in the math land, we really want you to do some extra critical thinking. So not only do we want you to look at an equation and be able to graph it, we want you to be able to work backwards and say, hey, this is some information from the graph. Can you write the equational line? And that's what we'll be covering next. Finding the slope of lines. Now, there's a couple different techniques that you can do here. Here I was given 2 points, 2, -4, and -3, 2. I plotted those 2 points on my grid. Now, if I want to find the slope between those two, I can just count. I need to find out how far vertically I go and how far horizontally I go to get from one point to the other. So I can start on the point on the left. Doesn't really matter which one you start on. I just like to go left to right. And I can count. Remember, I want to go how far vertically. That's up and down. So from this point, I'm going to count 1, 2, 3, 4, 5, 6. Now I stop here because now I'm straight across from my point on the bottom. So I moved 6 steps, but I moved down 6. So to indicate that it was down 6, I need to put a negative. So that was my rise, was -6, or the vertical change. And now that I'm down here, I need to find out how many steps it takes to go over to my other dot. That's the horizontal movement. So we count over 1, 2, 3, 4, 5. So we went over 5. That's our run is 5. That's your denominator. So the slope between these these 2 points is -6/5. That's the slope between the points 2, -4 and -3, 2. Well, that's all fine and dandy, and we can count all day long how to get from one point to another. However, it's going to take a whole lot longer, especially if we have large numbers. So we need another technique of how we can do this maybe a little bit quicker. Well, you have to think about what we're trying to find. To find out our rise, we're finding out the distance that we go from this y value to this y value, or vice versa. The distance is found by finding the difference. Difference in Mathland means subtraction. So to find out the distance between just the y values, essentially what we're doing is we're going to move this point from being over here to being straight underneath. To being straight underneath here, and we just want to find out this distance. That distance is our rise. Well, to find a distance, we subtract the y values because it's a y coordinate. Our y values, though, you need to remember, are the second values. This is an x and a y. This is an x and a y. So to find the distance between there, we subtract the y values. If I start with my first y value of -4, and I subtract my second y value of 2, -4 take away 2 is going to give me -6. That's exactly what we counted before, 6 in that negative direction. So now to find out how far we run, or the x value, we're going to do exactly the same idea, but now that we have our point down here, we want to say how far does it move from here to its original location. That is the run, or your x values. Rise are y's, run is the x. So we count that distance, 1, 2, 3, 4, 5. Once again, though, we can do that mathematically by finding the difference of our x values. We started with an x value of 2, and now we're taking away, because to find a distance you subtract, we're taking away -3. So the formula would have a negative, or a subtraction sign, but the number that we're taking away is negative. We need both of them in there. 2 take away a -3, subtracting a negative is the same thing as adding a positive, is how we get 5. And once again, we have the same rise over run of -6/5. Now, what happens if I would have decided to choose the other point instead? Here I started from -4 and I subtracted 2. What if I thought this was my first point and I subtracted that way? Would that change anything? Well, let me rewrite those points up here. We had 2, -4, and we have -3, 2. What if I thought the difference, or the distance, was from taking the 2 and subtracting the -4? Well, once again, it's 2 and you're subtracting a negative. That's negative is never the same as that subtraction symbol. 2 take away a -4. 2 negatives in a row is the same thing as adding a positive. Now I have a distance of 6. Uh-oh. Is that going to give me a different answer than what I did before? Well, let's continue on the process. If that was our rise, let's find the run. Now, since we started here with the y value, we have to start here with the x value. It stays consistent that way. So I'm going to start with the -3, and I'm going to take away my 2. -3 take away 2 is -5. Is -6 over a +5 the same thing as 6 over a -5? You bet it is. Those are the same thing. Remember, there are 3 ways that you can write a negative fraction. A negative numerator, as we have here, a negative denominator, as we have there, or you can make the whole fraction negative by writing the negative out front. Your textbook likes to do this. I like this way. And this we get a little scared at because we have the tendency to lose it, but it is still a valid point. All 3 of those is the correct way of writing a negative fraction. Alright, so let's tie this together. If we're finding that distance between the y-coordinates and the distance between the x-coordinates by subtracting them, I bet there's a formula for this. And sure enough, there's a slope formula. So, when given 2 points, find the slope by using the formula. What's the formula? M is equal to y2 minus y sub 1 all over x sub 2 minus x sub 1. Oh, that's a little scary. It shouldn't be. Now these little 2's and little 1's is indicating that you have 2 different points. Because remember, all of our points are x and y values. How do you know which one we're talking about? So we call it x1, y1. This is our comma separating. And x2, y2. Those are our points. So it does not matter which point you call x1, y1 and which point you call x2, y2. The key is that the sub numbers are the same for the x and the y in that point. These are both 2's, these are both 1's. That's the important thing. But we just showed in the previous problem that you get the same answer either way. Doesn't matter whether you start with that first point or the second point. Remember, here we started with the -4 and we took away 2. And then we started with the 2 on the bottom and took away the -3. But then we did the same problem in reverse by starting with the 2 over here and then taking away the -4. And then on the bottom it was the -3, take away the 2. And either way we got the same answer. The key is to be consistent. Wherever you start on top, you have to start with that same point on the bottom. Wherever you start on top, you have to start with the same point on the bottom. And also be very careful with negative signs. The formula says subtract. That's not the same as if the number that you are subtracting is negative. So keep that in mind and be very careful. Now we're going to have to know how to find slope in order to help us write equations of lines. And that's the last section that we'll be needing to go through today. A great thing in Mathland is that we really want you to express your understanding of the concepts. We want you to be able to not only go forward and regurgitate that way, but to process that information that well that you could also work a problem backwards. That is a higher level of understanding, a higher level of thinking. That is improving your brain power. And one of the things that they do this chapter for that is that they make you write an equation of a line. So if the directions say write an equation of a line or find an equation of a line that ... and given information, it means that we need to write an equation of a line that our final answer will be in the form of y equals mx plus b. That is our slope-intercept form of an equation of a line. It shows the relationship between x and y, which is visually a line. So our answer should be in that form, but we need numbers for m and b. So whenever it says write an equation of a line, that tells us that we have two goals. Our first goal is to find m, the slope. The second goal is to find b, the y-intercept. Those are our two goals whenever the directions say write an equation of a line. Sometimes it starts off kind of easy. So this is the process. These are the three different examples of things that you might have. The first question might say write an equation of a line that has a slope of 73 and a y-intercept at 0.54. Well, this is pretty easy. Why do I say it's pretty easy? They give us all the information. Remember, it said write an equation of a line, so I'm looking for m and b. And then I'm going to plug it into y equals mx plus b. In this particular problem, it tells us the slope of 73. So m is 73. Right in front of the x goes my m, 73. Now the y-intercept is not always a y-coordinate. The y-intercept, remember, is when x is 0, then the y value is our b. Well, they already gave us that, so our b is 54. So now I just replace that in the line with 54. So the equation of a line that has a slope of 73 and a y-intercept of 0.54 is y equals 73x plus 54. And we're done with that problem. That's not so bad. Alright, so obviously they're not always going to be that easy. They're going to give us harder things than that. So they might say, write an equation of a line, ... that goes through the point -3, 0, and has a slope of -2. Once again, because the direction said find the equation of a line, I'm thinking of y equals mx plus b. And I need to find those two values. Once again, this is a little bit on the easier side because they give us m again. Slope is given, so I just need to plug that in here. Now, this time, though, they don't give us the y-intercept. Remember, the y-intercept is when x is 0, it's the y value. Since the x-coordinate is not 0 in the point that they give us, the y value cannot be the y-intercept. So then we sit there and go, oh, rats, now what do we do? Well, you do still need to remember that this is an x and a y value that are paired together. And that means that that's going to hold the equation true. So in my y equals mx plus b slope-intercept form, if I plug that x and y in, my left side will equal the right side. So when y is 0, Oh, and m, oh, that's right, we know what that is. M is negative 2. And when my x is negative 3, then I have a true statement. Well, we don't know what b is, but now we have the other 3 letters in my y equals mx plus b form. So now I can solve for b. We simplify. Negative times a negative makes it a positive 6 plus b. And then to get b by itself, the 6 is positive, so to move it to the other side, we'd do the opposite operation. So we're going to have to subtract 6. Whatever you do to one side, you do to the other side. 0 take away 6 is a negative 6. 6 minus 6 is 0, that's why we did it. And then you'll have your b. So we now know that b is negative 6. So we can go right up into our equation here. Y equals negative 2x plus a negative 6. And that is the equation of the line. Do I have to do plus and negative? No, if you don't want to write it like that, you don't have to. It is equally correct to write y is equal to negative 2x minus 6. Because adding a negative is the same thing as subtracting a positive. Either one is okay, but we do always put the variable term first and don't lose that negative in front of the 2. So if they give us a point and the slope, we fill in our slope in our equation, then we use the point back into y equals mx plus b, we replace the 3 things that we do know, which is the y, m, and x, to solve for b. Do a little solving, some little algebra equation, and then replace that value into the equation up here. Now remember, this is a key thing. Right here, b equals negative 6 is not an equation of a line. Not an equation of a line. This is telling me the value of the y-intercept. It's not an equation of a line. To be an equation of a line, we have to be able to plot it on our coordinate plane. Our coordinate plane only has x's and y's on it. So to be an equation of a line, I have to show the relationship between x and y. b equals negative 6 does not tell me a relationship between x and y. It's simply telling me the value of the y-intercept. It's letting me know where that graph is crossing the y-axis. It's not an equation of a line. b equals a value is not the right answer. So these first 2 examples were a little bit on the easier side. We had one in which the slope and the y-intercept was given. We had another in which a point was given, but the slope was already also given. So then what happens if I'm not given either of those things? What happens, and how do I find the equation if they tell me to write the equation of a line that goes through and they give us 2 points? Write the equation of a line that goes through the point negative 6, 1 and the point 2, 3. How do we write that equation of a line? Well, same things go as it did before. I'm still looking for y equals mx plus b. I'm still trying to find, because my goals, find m and then find b. Those are my 2 goals whenever it says write the equation of a line. We always look for a slope first, mainly because they sometimes give it to us. In this case, they did not. But we have 2 points. And what we just went through on the last segment was finding the slope when given 2 points. We used the slope formula. Which is m is equal to y2 minus y1 over x2 minus x1. Once again, it does not matter which value we stick in for x and y, or the 1 and the 2, as long as they are part of the same pairing. So if I go through here and I start off y minus y, that's going to be 3 minus 1. Now because I started over here with y, right underneath it I have to start with its partner, 2. So underneath it's 2 minus, and what am I subtracting? Oh, a -6. Remember that -6 is not that subtraction sign, so I need to put in parentheses my number -6. And now we simplify. 3 minus 1 gives me 2. On the bottom I have 2, and I'm subtracting a negative, 2 negatives in a row. You change both of them to positive, so it's 2 plus 6, which is 8. And then you reduce your fraction. 2 goes into 2 once, 2 goes into 8 4 times. So my slope is 1/4. Once again, I go back up to my line. I know that this is what my answer is going to be. I replace my m, that's the number in front of x, with 1/4. Oh, so how do we find b at this point? Well, to find b, we do exactly what we did on the previous problem. We can choose one of our points and the slope and plug it in and solve. Now we could plug this first one in, but there's a negative, and 6 is kind of a big number. That kind of is scary too. Over here I have 2 positives. I make less boo-boos if I have positives, so I'm going to use that as my x and my y. It does not matter though which one you choose. It does not matter. So once again I'm going to go into the equation, but now I have an x and a y value. So we're going into y equals mx plus b. We're using the point 2, 3. And the fact that we just solved that slope is 1/4. And we replace the values that we know. Be careful here. Y is not the first number. Y is the second number. That's one of the things that we make mistakes on. M is 1/4. X is 2. And then plus b. 3 is equal to, oh, I can do a little reducing here. Remember, that's just 2. It's 2 over 1. 2 goes into 2 once, 2 goes into 4 twice. So I'm left with 1 times 1 on top, and 2 times 1, which is 2 on the bottom, plus b. Now we have to get the b by itself, so we're going to have to subtract the 1/2. I can't take 1/2 from 3 because they don't have like denominators, because 3 is 3 over 1. So in order to simplify that, I'm going to have to get a common denominator. The common denominator between 1 and 2 is 2. So to make this 1 into a 2, we'd multiply it by 2. But if I do that to the bottom, I have to do it to the top as well. So that gives me 6/2, and I'm subtracting 1/2 to equal b. Multiplying top and bottom by 2 over 2, because that's just a funky form of 1. Now that 3 is the same thing as 6 divided by 2. And now I subtract my numerators. 6 minus 1 is 5, and the denominators stay the same. And I find out that my b value is 5/2. So now I can go back into my equation of a line that I had. Y equals 1/4 x plus, and my b value is 5/2. Do not switch it to 2.5. That is not proper in algebra. It's okay when you were learning your arithmetic to say, oh, that's 2.5 cups of sugar. We're not into that. In algebra, we leave everything as a reduced fraction, but we do not convert them to mixed numbers for a couple of reasons. One, if you look at it as 2.5, too often that looks like 21/2, and we don't know what that means. Also, this also looks like it could be 2 times 1/2, which is a different result than 5/2. 2 times 1/2 is 1, not the 5/2 that we need it to be. And finally, if I need to do anything with this number, the first thing I would have to do is convert it back to an improper fraction. And in math land, we're really lazy. We don't want to do something just to have to undo it later if it doesn't make any sense to us. So leave your fractions as improper fractions, but reduce them. If this was a 10/4, that would be wrong. You have to reduce it to 5/2. Reducing is different than converting. Do not change it or convert it from an improper fraction to a mixed number. We like fractions. We don't care for mixed numbers in math land. Little side note there. So we did come up with our equation here, y equals 1/4 x plus 5/2. Now, how did we do that again? When given 2 points, as we were there, if you're given 2 points, and you have to write the equation of a line, the first thing you do is find the slope by using the slope formula. The second thing you do is pick one point, it does not matter which one, and the newly found slope, remember the point is an x and a y value. Plug into y equals mx plus b and solve for b. Because the point would give you an x and a y, the slope gives you m, that gives you 3 of the 4 letters, so you can solve for the 4th letter. And then finally, now that you have m and you have b, write the equation of a line in the form of y equals mx plus b. Okay, the b that we got here goes into this space, and the value that you get up here goes into that first blank. And that's how you write the equation of a line. I hope you've enjoyed these extra little tidbits from week 4, module 4. We're a third of the way through our course. Make sure that you rewrite notes so that they make sense to you. Read the chapter, highlight things, take notes, practice problems. Don't just do the 10 problems that are your assignment. Practice problems out of the book. That's how you're going to do it right, and you're going to remember it. If you have questions, ask. Okay? Good luck and happy graphing.